Hello, I'm Farhad Fallah. In this video, I'm going to show you how to use Aldec's HES DVM board compiler feature on the AWS cloud to prepare custom prototyping board files for using in HES DVM. Before jumping to use the board compiler tool, let's find out more about its use cases. Any ASIC and FPGA's design requires to have a prototyping board to do the final verification test before tape-out. The prototyping board is selected by parameters such as size of the design and required peripherals. Aldec provides several single to multi FPGA prototyping board which can be found on our website. HES DVM supports all Aldec prototyping boards for partitioning and prototyping. In case you are using a custom board, board compiler tool comes to play to prepare DVM compatible board files. Board compiler is a command line tool and can be run using an AWS machine terminal. HES DVM help contains a detailed document about board compiler. To run the HES DVM help, you can click on the icon HES DVM CE help. And if you search for board compiler, you can see that document right here. Board compiler is located under HES DVM installation directory. So I changed the directory to where I installed HES DVM. Here's board compiler. I can also run help using board compiler -help command. Board compiler has different options. For example, import Verilog. By using the import Verilog, we can compile and import user-defined Verilog or system Verilog board files. Another feature to mention is list-FPGAs. HES DVM includes a library of Xilinx FPGA devices, and by using list-FPGA we can list all the supported FPGA chips in the command line. There is also an export-FPGA command by which we can export the selected FPGAs from the list to Verilog source file. Now let's take a look at the FPGA's chips that are fully supported inside HES DVM library. To that I type board compiler list-FPGAs. These are the lists of all the supported FPGA devices. If I want to find out if a specific chip is supported, I type board compiler is the -FPGA, and I can use this attribute to, for example, VU9P devices. If I want to find them, enter. Yes, it's showing me what are the VU9P chips that are supported inside DVM library. For this video, I'm creating a custom board model with ultra scale 440 devices. So I'm gonna search for 440 to see if I can find the device that I need. Here is the device that I'm using for my model. Now I need to export this file to my projects directory to be used for creating my final board file. To do that, I use export command, compiler, export FPGA. So I need to use the name of the device that I'm going to copy. And then I use -O. -O is used to create an output, to output an FPGA, and then the destination would be home, C2, board compiler, and then I'm going to use my FPGA folder. This file is written. I'm gonna check if the file is already written there. Yeah, file is written already in my project folder. Now that we exported the Verilog file for the FPGA chip, let's take a look at inside this file and see how it is created. Here's the module. Inside the module, we can see all the pins, locations on the FPGA device, and there are almost 1700 lines which represents each pin and where it is assigned to. Additional information about the FPGA chip can be passed by using Verilog attributes. We have FPGA technology, number of registers, lookup tables, DSPs, BRAMs, and URAMs on the top of the file. Other than the FPGA chip Verilog file that shows the I/O pin assignments of the device, we need to have the custom board Verilog or system Verilog file, which contains the information about the interconnections between the FPGAs and also the global signals used on the board. This file is usually provided by the board supplier, or the user has to define it. Now let's take a look at the board file that I prepared for my custom board. First, I need to include the chip Verilog file that we just exported. We can use attributes to define default I/O standards for differential and single-ended interfaces, and then we start our module. This is gonna be our chip name. So as on the board I have 4 FPGAs, so we're gonna see 4 module instantiation of this device. There are different attributes that can be found inside the help. They are called connection attributes for HES DVM. There is con underline name, I/O standard, global signal, frequency, ICC clock, ICC reset, and single-ended. Each one can be used for one functionality. For example, we can create global signals with a specific frequency that we want, and also we can create ICC clock or ICC resets using these attributes. This is ICC resets we have here. Wires are used for interconnections between FPGAs, chip-to-chip interconnections. And then if for any reason we need to force one signal to be single-ended, we can use this attribute for single-ended to make that signal a single-ended interface. Okay, let's jump into the first instantiation that we have for the chip right here, FPGA 0. Before we start jumping into the pins, we can use again the attributes to define information, specific information about the chip. We have the part name, we have the technology, we have number of registers, number of lookup tables, number of BRAMs, URAMs, and DSPs. inside this module we can see that, for example, W3 is connected to what interface on the board. There are 4 of these modules inside the board file. You can see them throughout the design. And for any reason, if we need to modify this file and use any connection attributes, we can just go through that line that we need to change. For example, if any problem happens with the PCB and we need to make some changes in the wiring and all, we can use the connection attributes to make those changes. Okay, so far we got the chip Verilog file, and also we got the board file, which shows the interconnections between FPGAs and also global signals on the board. Now we need to use board compiler to create the file that we need to import inside DVM for our custom board. To do that, I prepared a script. In this script, we need to get the board name as an input, and then we start the board compiler using the import -verilog, and using include, we are gonna include the chip Verilog file, which I exported it inside my FPGAs folder, and then we define the top module for our design, which we get it through an argument inside the board compiler, and then we input the board file, system Verilog board file, and at the end we output a .board file, which is going to be used inside DVM. And the line 13, we say report the level 1. If we put 2, we are going to get more information on the terminal when we run this script. So now I need to run the compile board.sh. To do that, I just type compile board and then the name of the board. Paste it here. So the output says that there are 4 FPGA chips, and then 4 global connections. We have 42 single-ended chip-to-chip connections, 408 differential connections, and then 120 MGT, and 634 other connections which are not active at the moment. Now that we created the custom board file for DVM, let's see how we can import it inside HES DVM and use it. So I'm going to run HES DVM. In another video, I went through all the process of adding source files, partitioning, and also creating the output files, required files that we need for to be used inside Vivado to do the place and route and program the FPGAs. You can find this video on our website, but for now I just want to create one new project. I'm going to create it under, I've already prepared one project which I use in that video. This is a new directory that I'm creating. As I'm prototyping vertex ultra scale. I need to create one library. Now I need to use my .do file to run the compilation. So by using a .do file, I can just select any line that I need to compile and run only these lines. If I go back to library, I see all the compiled source files. I need to use the top module and run the elaboration. It's going to take a little bit of time. And once the elaboration is done, under the design, I see the board information on the right side. So here I can just set the board. If I choose custom board, and then from the path I go to the path of the board compiler project, and then the .board file. I open it, click OK. So on the right side I can see that a lot of information about my board, from how many single-ended interfaces, differential interfaces we have, how many lookup table, registers, PRAM, URAMs, and DSP blocks on the boards on each FPGA. I can even open up this FPGAs and see they are connected to what other FPGAs on the board. For example, FPGA instance 1 is connected to 2 and 4, and then I can see how's the connections, how many single-ended and differential connectors are between them, and then the same thing for other FPGAs on the board. And then also I can see the ports and signals for my designs right here. So we come to the end of this video, and for more videos just search on our websites, and we are gonna send it out soon. So it brings us to the end of this video. Thank you so much for watching. For more information, please visit our website at www.aldec.com.